So how do you pick a best attribute? And really what you're deciding is you could pick any attribute to split on, and it would result in a different partition of the data. So how do you decide that one partitioning of the data set is better than another partitioning of the data set? So let's take our original data set. We had 9 yeses and 5 nos. We could either split it on outlook, or we could have tried to split it on wind. So what's the difference? If we split it on outlook, we end up with 3 subsets: sunny, overcast, and rain. One of these is pure, and 2 of these are impure. If we split on wind, we end up with just 2 subsets: weak and strong. So this would have 6 positives and 2 negatives, and strong would have 3 positives and 3 negatives. So just looking at these 2 splits, which split do you like better?
Outlook.
The outlook. Why do you like it better? It has a pure subset. Now, if you were looking at the 2 subsets of the wind, the weak and the strong, do you like one of them better than another? Yeah, the weak is better, even though it's not pure. So in general, what you want out of a decision tree is you want a split that gives you subsets that are heavily biased towards either positive or negative. And why is that? That's because if you have a subset that's mostly positive, that means that presence or absence in that subset tells you a lot about what you're trying to predict. Right? So if you have a mostly positive subset, it's a good thing because it tells you that in that subset all entities are likely to be positive. There are some negatives, but it's a lot better than strong. Right? In strong, it's 50-50. You have no idea. Being in that subset tells you no information whatsoever about whether you're more likely to be positive or negative. So that's what you want. You want to come up with some sort of a measure, some sort of a formula that captures the purity of the split. So basically what you want is you want something that tells you, so before the split, you were uncertain about which nodes would be positives and which would be negatives. And hopefully after the split, you are more certain. So if you have a pure subset, that you're completely certain. If you have a 50-50 subset like that, then you're completely uncertain. So what you want is you want splits that give you as much certainty as you can get. So and here are examples, right? So the overcast, that's a completely certain. You're completely certain that any instance falling in here is positive, so it's a totally pure subset. And that one, you're completely uncertain about whether the instance is positive or negative. So you want some measure like that, and the trick here is you have to, this measure has to be symmetric, right? So we cannot use something as simple as the proportion of positives in a subset, right? So proportion of positives would work here, right? It's 4 out of 4, 100% positive, and it's only 50% positive here. But you would also want to have a high number for a subset that was all negative. So if you had a subset that had 4 no's and 0 yeses, you wanted to have a high purity score, even though the probability of yes would be 0. Right? So you want something that's symmetric, that doesn't care about whether it's positive or negative, that just tries to pick out the purest subset.